Let's compare both generations of ball clock. This one on the left is the first generation, this one is the second generation. So this one was manufactured from 1990s until the end of the this one is the original Arrow handicraft design that was introduced in 1978 and continued through the 1980s. So as you can see, they are both same size. There's really no difference. The dust cover, the acrylic dust cover, a slightly different shape. So that's the L shape of the first generation. It is smooth here at the edges, whereas the second generations always had this base kind of accommodating widening at the bottom. The reason for that was to prevent the base going inside this tapered shape of the acrylic cover and causing cracks. And here actually you can see the crack in this in this cover because the base was pushed too far in and it split. So this is the difference. The later designs of the first generation also had this this shoulder here at the base to prevent it going in. The size of the the acrylic cover, the size of the clock, as I said, is the same. It is 25.8 centimeters times 16.3 centimeters times 20.5 centimeters. The other difference in the acrylic cover is the support for the motor in the second generation. I'll try to show this a little bit closer here. Here you can see the support for the motor. So the motor, there are some sort of like tabs that make the motor a little bit more secure and the arm not wobbling forward and back. Whereas here there is no any engagement between the clock itself and the acrylic cover and dust cover. The cover is for the sound protection, for the noise protection. These clocks can be quite noisy, and also for the dust. So when we remove the cover, we can talk about tracks. So here are plastic tracks that the balls roll onto the platforms that tilt, and then we have some gates. Well, in fact, one gate that sits here. The design is exactly the same. There's no difference in height, in the number of platforms, in the shape of the platforms, although they are not interchangeable. Because the first generation was self-assembly snap fit, so you can actually take this apart and put it sort of like in flint of the flat box, whereas this was always pre-assembled in the factory. Second generation always came pre-assembled, and there are also some screws holding elements to the base. So it would be very difficult to get this apart. So that's the difference. There is some lettering, obviously, slightly different here on the platforms, but essentially everything else is the same. Balls have the same size. It is 3/8 of the inch or 9.5 millimeters steel balls. Slightly bigger ball is this black one here. This one I believe is also 9.5 millimeters. There should be a bigger ball here that I think is 10 millimeters, if I'm not mistaken. Here this one is missing. I just sort of like put the normal 9.5 millimeter ball here. The biggest difference between both generations of ball clock is the motors itself. So this assembly here that drives the arms. This one is AC motor, this is DC motor. This is high voltage, this comes from the mains. This is 6 volts or battery, or like in this case, it is powered by USB, 5 volts. It works quite nicely out of 5 volts. You can also see the seconds indicator here in the second generation, whereas this one doesn't have that. And the next big difference that you've probably already seen is that the arm on the first generation rotates continuously at the speed of 1 rotation per minute, whereas here the rotation is intermittent. It does 10-second cycle to get the ball onto the track, pick up the ball here from the cue, and then get it on the top track, and then it just waits for the next full minute to do that. And here we go, right? Picks up the ball, drops on the track, and then after doing a quick full rotation, it just stops. And that's the main difference. Let's look at the back of these clocks, because that's where you can see the big differences. We put actually covers to the side, and let me move the camera to the back of it. So this is how the clocks look from the back. You can see AC motor here, and then the lead goes to the just normal wall socket. 230 volts, 50 hertz for European version. So there will be different between the US versions that run from 110 volts and 60 hertz, and European versions. If you plug the American version into the European socket, you'll get basically clock that runs slower. It's probably about 10% slower, whereas so you need to have the not only voltage converter, but also frequency needs to be converted as the motor synchronizes with the mains frequency. It's much simpler design. So basically the arm is directly on the motor. This motor is a replacement motor. This is not how it originally looked like. There should be a plastic box around it. So normally it was insulated here with the plastic assembly. But these Intermatic motors that were originally they were all failing with time. There was one plastic gear that was disintegrating over time. Whether you use it or not, it would basically age and turn into pieces. So that's why most of these early Arrow clocks are not working anymore unless you can find the replacement parts and repair the motor. The repair is quite easy, but you can find the parts, and the parts are available, but they are ridiculously expensive from some online sellers. Definitely not worth it. So someone decided to actually change the whole motor here, which works quite well. So that's the basic difference. You can see that shape of this plastic box is different, that holds the whole motor assembly. Here there's actually 3 parts to it. There is a quartz clock, almost like normal quartz clock that you can find in battery operated wall clocks. and that's why the second sort of like jump here, very similarly to the wall clocks. There is a electronic circuit that provides power to the clock and to the motor that is intermittently powered then every minute for this 10 seconds, and rotates the arm. Here at the bottom there is a battery compartment for C-size batteries. There are 4 of them. You need 6 volts to operate this clock, or you can directly power them from the USB socket. So there is a USB charger, and there is just USB cable with a converted end to put this to provide 5 volts into this second generation clock, and it works quite nicely. The important bit is to remember the polarity. It has positive outside, positive pin or positive sleeve is outside, and the negative pin is the one in the middle, which is quite different to the usual arrangement of sockets. And here it is, the battery compartment. Nothing special about them. They can be corroded occasionally. There's cover for the battery compartment. And as I said, the trucks are similar. Here is this clock, seconds indicator, and here you can see some action, this intermittent action of this of the time machine. So that's the second generation. The first generation, much simpler arrangement, assuming that your AC motor works well. So again, it's going to pick up the ball in a moment. And then at the same speed, it's going to deliver it to the top track. Not sure if you can hear the difference. Here is just a ticking sound. One second at a time, and here you can hear the motor running, basically. So that's the difference in how they sound. I think this is the first generation currently with this replaced motor is probably a little bit noisier. The second generation you can very clearly hear it, but that's the sound of the ticking clock. So I hope I covered most of the differences, and now you'll be able to tell which one is which.